So we said that in a one sample t-test, you compare a particular mean of a particular sample with an already established mean figure. Okay. So let's say, for example, just a minute, let me open up something. Okay, let's take this data for instance. Just that data. Okay. Let's say you have that data. Um, let's just say these are scores of students. And now let's say there's an assertion that the average score of the students is 50. That's on the average. The students, maybe in a particular class, usually have a score of 50, right? So what that would mean is that HO would be X equals 50, while H1 is what's H1? That's alternative hypothesis. Will be the mean is not equals 50. Okay. Okay, so now to do a one sample t-test in this case. Oh, I forgot we are doing. Okay, Excel does not really have provision for one sample t-test actually. Excel doesn't have provision for that. You say you have to provide the two arrays, the two samples. Yeah. Okay. But there's usually a way we get around that. I'll just show you how we get around it. If you go to data analysis, t-test, see the options here. T-test, paired two sample for mean. T-test, two sample assuming covariance. T-test, two sample assuming unequal variance. Okay, so the way to do that, or let's just, okay, the way people do that is just put 50 all through here, okay, and take this as the second sample, right? So in that case, if you want to do the t-test, You can go through data analysis, click on data analysis tool, then go to your t-tests, t-tests, test sample, to sample assuming covariance. Let's say we use this, for example, the first value one range, just select value two range, select the second one. Then you click in the choose where you want your results, and then click on OK. Okay, so this is an indirect way of doing that. But when we get to arrow, we'll talk about the one sample t-test properly. Okay, this is actually not one sample t-test. Here, we're just trying to do something that will look like the one sample t-test. Now, if you look at the result here, it tells you that the mean of the first one is this. First variable, second variable is 50, first variable 56 points something. The variance is, um, observations, observation 1616, pooled variance, that's combined variance. Then you have hypothesized mean difference 0, degree of freedom 30. So now where you come to is this p-value two-tailed, which is this. This is the p-value. So is this a high value or a low value? Is that a high value or a low value?
A low value.
A low value. Okay. Are you sure?
It's high. It's high.
It's high, yes.
That's 0 points.
It's higher than what?
0.05, yeah.
Thank you. So it's high value. So when P is high, what do you do to the null hypothesis? When P is high,
Is it
you reject
disregard the non-neglected?
you reject the null hypothesis.
Yes.
Okay. Which means the difference between these two is statistically significant. Okay. Which means this difference you are saying it's large enough for us to say that they are truly different. It's not likely to be by chance. Okay? Not likely to be by chance, which means the scores, these people, these students, they actually score more than 50% on the average. Does this make sense?
Yes, sir.
Okay, so this is really not a one sample t-test, but it's an indirect way of doing one sample t-test. Okay. Like I said, when we get to arrow, we'll see the real one sample t-test. Now let's look at the pair t-test. Pair t-test is a situation where it's a situation where you take samples, two samples from the same group of entities or objects. Okay. So let's say, for example, assuming we have some data. Let's say we have some data that represents let's just change some figures here. Before, after. Before, after. Okay, so now let's say this is the data of the scores of students. Let's say you have information about the scores of students in maths, and let's say a decision was taken to give the students extra lectures, 1 hour extra lectures each day. And now their scores was taken before beginning extra lectures. Then after the extra lecture starts, they were tested again after they have been taken through extra lectures for a period of time. They were tested again, and then their scores are gotten as well. And now we want to see if there's a statistically significant difference between the two sets of scores. We want to see if there's statistically significant difference between the mean score without extra lectures and the mean scores after extra lectures. So this is what the kind of thing we do with our paired t-test. This is a paired t-test now. Let's say, for example, let's say this is the registration number of the students. Student 1001, 1002, and so on. Okay. So you see that these two scores belong to the same student. These two belong to the same students. These two belong to the same student, and so forth. Right? So this is a paired sample now. This is a paired sample. So if you use this kind of samples for your t-test, that will be a paired sample t-test. How do we do that? We can do that using our data analysis. You could do it with the t-test, just t.test function. Equals key t.test. Take the first sample, comma, the second sample, comma. What was it asking? One-tailed or two-tailed distribution? We are talking of, what do you think we should take here?
Two-tailed.
Okay, well, let's use two-tailed. We want to see if there's a difference between the two, whichever way. Then Now it's asking for the type of t-test. Is it what type of t-test do you think we are dealing with? Head, right?
Spread.
All right, so this is the p-value we are getting. This is the p-value we are getting. So let's find the average here. All right, so wow, they even became worse. Well, in this case, you don't have anything to test. This is not to make it make sense. If it's like this, no need to test because the lecture is not working. Are you following? Okay, is it clear? But if it's
Yes,
like
sir.
this, if it's like this, so we want to test if there's statistically significant difference. That's when it will make sense to test. Okay. Okay. This is the first. Second. Okay, so now this is our p-value. Okay. And this p-value indicates that what? Indicates there's a statistically significant difference between the performance after taking extra lectures and the performance before taking extra lectures, which means the lectures are worth it, right? Okay, because this number is less than 0.05. Are we okay? Is this clear to every one of us? Is it clear? Can I get your responses, please?
No, it's clear to me.
I hope it's clear to every one of us.
Hello, sir.
Hello?
Yes, it's clear.
Okay,
Yes, sir. I just entered, sir.
okay. Welcome,
I just logged in, sir. It's clear. Yes, sir.
welcome, welcome.
Good evening, sir.
Good evening. How was your day? Welcome.
Ah, we've been in the house since. Yes, sir.
Yes, okay, that's correct. That's correct. So you didn't go out for the
Yeah, because
protest.
of the protest.
Yes. So you didn't join them.
No, sir.
Okay.
Stay back. We're praying for those that went.
That
And
went.
we achieved the purpose.
That's good. All right. Okay. So all right, well done. So now that's the one sample per sample t-test. We also have the independent sample t-test, in which case the samples pertain to entirely different objects. Okay. For example, we are comparing. I mean, this thing is not all about scores. It could be that you are comparing the effectiveness of fertilizer, maybe after using the two different fertilizers to grow crops. You want to see which of the crops are heavier for you weigh them, okay, or something like that. or you use some feeds to feed fish, and then after you use two different types of feeds, and then you compare the weights of average weights of the fishes. Okay, you take a random sample of the fishes from one pond, from one pond, and then a random sample from another pond, and then you want to compare the averages. That kind of thing, you can use t-test for that. Okay. All right, so that also will be an independent sample t-test. So let's see how we can apply t-test to this. Caesar, let me just copy it out to avoid interferences. Let's go right down. Okay, so you paste that, and then okay, let's use the data analysis method this time around. Click on data analysis. We go to t-tests. Let's use t-test equal variance. Usually when you have the same number of items like this, usually equal variance option would work, most of the time. So let's take that. And then it's asking for the first sample, the second sample, and the second sample. So let's click this first range. Sorry. This first range, you highlight, please 1 minute. Okay.
Yeah,
Sorry. Okay, so here we just select the first sample. You click the next text box there, select the second sample. This time around, I'm using headings. So output range. Wow. Okay, output range. For the output range, I want to choose somewhere here. Click on OK. Okay, so what is this output telling us?
He's saying there is a significant difference.
Yes. You see the
So,
significant difference, right?
yes.
For both one-tailed and two-tailed. Okay?
Yes.
Yeah. So there's a statistically significant difference between Nigerian students and British students. In this case, it's saying that Nigerian students are obviously doing better than the British students. So this is how the t-test works here. Yeah. So that's the t-test. Okay, so now we are going to move on to another type of tests. Next, we are going to deal with another type of test, which is the ANOVA test.